This is a conversation with Jason Hoyle, a Principal Energy Policy Analyst. He specializes in energy and carbon markets, analysis of clean energy policies and regulations, and utility rate design. Jason orchestrated the first 16 International Hydrail Conferences in cooperation with local hosts in the US, Denmark, Spain, Turkey, England, Canada, Germany, and Austria. This is Energy News Biz Hydrail Interview Series. To support it, please check out our advertising options in the description. Thank you. And now, here's Jason Hoyle. Who is Jason Hoyle?
That's me, Jason Hoyle. I spent about 20 years at Appalachian State University in their Energy Center and their Center for Economic Research and Policy Analysis. And as part of that work, I started much right after graduate school. I earned an MBA. And one of my first assignments there this was back 2002, 2003, was to work on economic development related to renewable energy in North Carolina as part of the state energy plan. During that work, one of the initial things was sort of an informal census of renewable energy type companies in the state. And we discovered that we had quite a few companies involved in fuel cells and hydrogen. So we started convening a group, and that went forward from there.
So
right now,
how did you start attending Hydrail conferences? Was this the start?
that was one of the starts. Yes, we had contact with the then mayor of Mooresville, North Carolina, Bill Thunberg, and Stan Thompson, who's retired as a futurist, but very passionate about trains and technology. So they contacted me, and the three of us convened the first International Hydrail Conference in Charlotte, North Carolina.
Who are the most important people in Hydrail, in your opinion?
Oh, well, that's a tough one these days.
Let's say back then.
Back then, well, I would say, of course, Stan and Bill. They help kind of instigate this kind of global coordination, right, and communication, and help build the global network. Just think back a while, there was some researchers in Japan who were doing some early studies. Kaichiro Kondo, and there was some early work in Canada with atomic energies. I think Alistair Miller was one of the earliest participants. There were, say, Arnold Miller, I think in the US, had done some of the early projects and kind of prototype conversions of switcher locomotives.
And who are the most important companies that are in forefront of Hydrail?
Right now, I would say definitely Hydrogenics, which is now Cummins, Ballard Power, of course, on the fuel cell side. And you've got Alstom, obviously, with the first large commercialized kind of light rail hydrogen fuel cell powered trains. There's a lot of interest in Siemens, Stadler, most of the major train manufacturers now, and the fuel cell companies are kind of leading the way in developing products, locomotive mass transit products that are rail based.
What is the status of Hydrail in the US?
Very early stage development. I mean, there are some projects, at least one that is moving towards commercial implementation in California, which is pretty good for the US, considering we're talking about rail transit, which is only available in a limited number of places. Um, there has been some interest in other areas. Hopefully, once there are some hydrogen trains on the tracks in the US, um, that will prove to be something more places adopt now that they don't have to be the first. The DOE is also pushing, they also have some funding opportunities for these multi state hydrogen hubs. I think that presents some significant potential opportunities for the development of hydro.
What do you believe are the key benefits of this technology compared to traditional diesel powered trains? And do you think that hydrail technology will eventually replace diesel powertrains? Or will these two coexist?
Well, that's three questions in one, Ernest.
Sorry about that.
So that's okay. Let's see. Will hydro eventually replace diesel? I think yes. Um, over time, will they coexist for a while? Undoubtedly. I think the economics of hydro versus diesel really depends a lot on the specific train routes. Um, everything from elevation to distances between stops to how urbanized the route is, um, to frequency of stops. I mean, there's a lot of factors that go into the economics of a particular train power system. Some of the advantages are, or you have obvious emission advantages, right? Lower particulates, NOx. You avoid fossil fuels. You obviously don't have carbon emissions, at least from the train. Um, and then some of the other advantages. Well, also there's noise. You also have advantages from a longer term strategic standpoint for a location or a place that's considering adopting hydrogen. And adopting hydrogen perhaps in a bigger sense than just trains. But trains make a fantastic kind of initial foray, if you will, into the hydrogen economy because they established a large quantity of fixed demand that's fixed in terms of how much you need, how often you need it, where your refueling points need to be, so that it becomes one of the easiest kind of hydrogen-based transportation uses to provide a supply for. And once you've built out that basic, you've laid the foundation now. Right? You've got a certain amount of demand that is very reliable and consistent. So it's very easy to scale up from there rather than having to make these initial outlays into the production and the distribution and all the things that come with hydrogen that are all challenges. Now you can get a lot of that taken care of by fueling trains with hydrogen. Then it's much easier to expand a little bit to supply bus routes, a little bit more to supply industrial equipment or cars or other potential uses. So it makes a very cost efficient kind of initial platform from which hydrogen can grow in a particular place.
I like a lot the way you described it in a phases, but you mentioned challenges. What are some of the major challenges hydrail technology currently faces, and how do you see these overcome?
There's the obvious challenges with hydrogen as a fuel. Most of our fuels are liquid based. Hydrogen is a gas, at least in the sense that it goes into tanks. Um, that's one challenge. The production, where do we get hydrogen from? You need to get it from a non emitting source if you're going to maintain a zero carbon life cycle, in a sense. And so that leaves you with renewables and nuclear power, essentially. Um, that's a problem. Transporting hydrogen is always has its certain challenges. Um, even though that's a viable thing, it just depends on the scale that you're operating at as to the form you transport it in, and everything from cryogenic liquid hydrogen, which is a very large scale transportation system, down to what's going to actually fill up your car. Those are some of the issues. Um, as far as putting a fuel cell on a train for, say, light rail, transit applications, that's been done. I mean, it's they're in commercial operation. Most of the trains in Europe um, will be moving towards hydrail beyond just the ones that are already being installed. So there
There are
are.
attempts, yes, there are attempts, especially in Germany, but of course, in any new technology, they come with some issues. I don't know, have you read it?
I mean, there are some that have to be figured out, if you will. Um, Trains are a little bit different than some other vehicles because they tend to have a lot of vibration. Just because you got metal wheels on a metal track, it moves a little bit. Um, but those seem to be not issues that are significant barriers to the adoption. I mean, there is.
Are there any exciting developments or advancements in Hydrail that you particularly are excited about?
Well, I'm excited that the other major train manufacturers, the OEMs, are on board and that they're developing Hydrail train models, right? I mean, Siemens and Stadler don't have a fully commercialized train model, nor does Bombardier, but I think they're moving in that direction and they're in development. And so once you have all of the major manufacturers offering hydrogen powered trains, it becomes a much easier decision for planners and local politicians that are making decisions about the future of transportation infrastructure. So, now we're not saying we're going to spend a bunch of money to buy something that doesn't even exist. It's now we've got these choices that we can compare, and hopefully there'll be some competition in the arena at some point, and hopefully that competition will work out in a way that it it's much more the hydrogen option versus diesel or overhead electrification, right? That's actually another big advantage in intracity transport, is that it's much easier to maybe this is the weird way to say it, but to retrofit a city for hydrogen trains that never had train-based transportation than it is to try to retrofit, and shoehorn overhead electrification. People don't like that if they're not used to it and haven't seen it. Plus, you've got all the other infrastructure was not designed for rail-based, electrified rail. So you've got issues with bridges, electric utilities, potentially other utilities, road crossings. There's lots of complications if you try to overlay an electric-based rail system into a city that never had it. But it's much easier to overlay a hydrogen rail-based system because you avoid all of the additional infrastructure. And all you need is the rail.
And the high percentage of retrofit should take place. Do you agree?
I mean, I would like to see more kind of cities in the U.S. in particular, adopt more mass transit options. I mean, there are some cities that are fairly have some fairly well built out kind of transit options, um, but we're talking a half dozen, maybe 10 at most. If you setting aside buses and things, but we're talking about fixed infrastructure transit options, and that's where you get your higher property values from. There's not nobody builds buildings because the bus route is going by there this year because they know the bus route might go somewhere else next year. But if you put a rail line down, well, that's not going anywhere, and so you get a big boost in property values and it really helps kind of steer development and more, um, I guess, densify cities, if you will. Focus development in certain areas, and it makes it much easier to move around. You know, I don't really drive in other countries, especially in Europe. There's usually a train I can take. Um, that plus, looking at the map and trying to figure out where I'm at and where I'm going is really not safe for anybody. Um, but
How do you think widespread adoption of hydrail technology will impact transportation industry?
I think it is going to be a very positive impact. The transportation industry, in particular cars, have been the automakers have been attempting to move into fuel cells, or at least talking about fuel cells since at least the late 1990s, and it's never really worked out. And I've always thought it's funny they're trying to, you know, they want to put the newest technology in the least cost, you know, use market, and that's not generally how things work, right? You generally start with the higher cost, higher value opportunities, and then you develop as you broaden your market. So that would obviously be something like trains and other, specialized heavy use applications, and then you move into things like buses and more heavy duty vehicles like trucks. And now, as you increase your production volumes, you make hydrogen more available, so the cost of that comes down. Then you get to car sized, if you will, fuel cells that, and now we you can couple those with plug-in vehicles. Now your all electric vehicle could conceivably be refueled and drive cross country nonstop. Um, and so I think in general that hydrel is just kind of the start of hydrogen in transportation, um, because it is actually more cost effective than diesel, and certainly overhead catenary infrastructure, um, for human transport. Not freight is a different issue, but and so now that there is a foundation, right, producers can refine the fuel cells, the hydrogen production products, and increase their production scale, which makes these things more affordable for an ever larger slice of the transportation market.
What role do you see government policies and incentives playing in the future of hydrail technology?
Well, I think they are critical. I mean, is there any major transportation infrastructure that doesn't involve government funding? I would say no, right? Government pays for the roads, they pay for the trains, at least up front and largely, heavily subsidized. And when they do that, they are making decisions on what the future of transportation looks like and all the implications that come with those decisions. And Hydrail offers an opportunity for them to choose, mass transit, that increases property values and encourages, well, densification of cities, and that opens a lot of other doors for other types of low emission transit opportunities. So ultimately, I think that the government decides: are they going to build more lanes on the highway, or are they just going to put more people on a train, and open up these opportunities, right? And that's a big piece of the decisions. I mean, obviously there are tax incentives and other opportunities that might arise. They have historically for different types of transportation technology, be it biofuels or electric vehicles now. So I wouldn't be surprised to see those either. But I think the biggest decision, the biggest role government plays is in those strategic decisions about what infrastructure they choose to build, and the vision of the future of different places.
Are there any potential risks associated with hydrail technology that should be aware of?
What kind of risks do you?
as a technology, using the hydrail technology, are there any risks? Also, in regard with hydrogen and the state it's used with.
I suppose there's some risks. Aren't there always risks? With everything. I mean, the hydrogen specific risks are, I think, you know, probably less in general than say gasoline. Gasoline is not exactly the safest of fuels. It's very combustible. Um, you can ignite it with static electricity. Yet people manage to fill up their cars without blowing themselves up all the time. There's not even a test. They manage to make it happen. So, I think the risks, to the extent that there are some risks, are easily manageable. I mean, if I was given a choice of, stand in a pool around leaking fuel, I would much rather stand beside a hydrogen tank than a gasoline tank because the hydrogen floats upwards, right? Gasoline pools at the ground where I'm at, um, just in case somebody lit a match or their cell phone sparked or something. I would rather have a flame shooting up than a big boom in a you know from gas fumes surrounding me. Um, but as far as risks, beyond, I mean, of course there are risks. There are always risks, but it's about comparing the risks. Um, what technology goes into mitigating the risks? And I think in general that you have. I feel like hydrogen comes out kind of ahead on the risk equation.
In your opinion, what role will hydrogen play in transition to low carbon economy, and how important do you think it will be in achieving global climate goals?
I think it could be very important. And it is pretty much the single zero carbon storable fuel, and that I think is always going to have some role in just the energy economy in general. Batteries can store electricity, and those work very well for a limited amount of time. You can depend on your battery for 4 hours or 6 hours or 8 hours, but after that, that's it. It's got to recharge. So you need to have surplus generation some point, right, to offset the charging of the battery, and then batteries can time shift to help match supply and demand over short periods of time. But hydrogen can time shift over weeks or months, potentially even years. You can also move power um, with hydrogen, like you can with other carbon fuels, which can also be important. That you can take it from A to B in a fairly dense form for a gas like hydrogen. At least if you've got enough of it, say, cryogenic liquid, you can store that and move it. Um, it's a that is important as well because particularly with when you get into low carbon sources like renewables, right, sometimes where the demand is not always where the supply is. And right now we build new power lines. However slowly we build them, we still build them to move power from A to B. That will always be an option and certainly something that's not going away. But there are still other needs that could be more economically efficient to meet by simply moving fuel from A to B or storing fuel for longer periods of time.
Are you currently working on any project related to hydrogen?
No, not beyond just tracking hydrogen policy, regulation and legislation in states. Not in my current job, no.
So you're tracking the policies. Can you comment on a current state of policies about hydrogen?
There are a few incentives for that include fuel cell vehicles or hydrogen production. Um, a lot of them focus on the green hydrogen or zero emission hydrogen. There are a few state renewable portfolio standards that allow for hydrogen generated electricity. at the federal level, they are still developing a lot of the safety protocols and requirements that govern hydrogen. But most of say, the large uh, electric generating turbines are now kind of hydrogen capable, if not complete 100% hydrogen, then say 50% or 25%. Um, and there are increasing efforts to trial hydrogen injection into natural gas pipelines in the U.S. in certain limited areas. That could also be an important feature of the hydrogen economy, leveraging existing infrastructure to reduce the carbon from existing fuels.
What do you see as the most effective strategies for reducing costs and making hydrogen more competitive with other forms of energy?
So you need scale, production scale. You need increased volumes of fuel cells being produced and put to use, as well as electrolyzers and other kind of supply related equipment on the hydrogen supply side. That's a big component. Of course, you need training, safety training. You need maintenance. You need engineers that are more familiar with hydrogen and how that can work within a system. And from a kind of a broader economic perspective, say, God, there are a lot of benefits of hydrogen that are not captured in market prices. And from my perspective, I feel like a fuel source that zero carbon, zero particulates, um, zero NOx, right, that doesn't necessarily consume finite resources. Um, these are important factors for long-term sustainability of any fuel, and hydrogen has a lot of advantages in those areas that are really not priced into the market right now. Think of them as hydrogen, you could say, has positive externalities, whereas a lot of the fossil fuels have negative externalities. And that we all incur the costs of those emissions and the consumption of finite fuel resources and the cost of climate change, right? But we don't really have a way to incorporate those costs into markets very well. Um, and so, factoring in all of these costs into fuel prices. Right now, we pay for those costs in hospital bills, lost labor productivity. How do we elevate our roads and our sewer systems so that they don't flood? Now we get twice as much rain when it storms, and right, extreme heat waves, extreme cold waves, atmospheric. What do they call them? Rivers in California, right? That dump 30 feet of snow. Um, so we all incur these costs in one way or the other, and whether it's indirectly through these changes, dealing with these changes and the impacts of using fossil fuels, um, or not, we incur those costs. And so the more we can put those costs into the market price, then the more accurate market signals will be.
The company that you're working for issued a report on hydrogen policy landscape. Can you tell more about the key objectives and findings from this report?
Um, Not specifically off the top of my head. There, we we do a lot of state policy analysis in a lot of different areas. Some reports on electric vehicles. We do have our hydrogen product is fairly new, um, and it does cover things like hydrogen and renewable portfolio standards and hydrogen incentives, hydrogen mix and integrated resource planning, and other utility planning developments. Um, Most of those are related to regulation and legislation. But as you can imagine, it's a very new area in the US in terms of activity. And there are occasional, I guess, occasional bits of activity, kind of pilot installations and some kind of test sites, but utilities right now in the U.S. largely aren't installing hydrogen fuel cells as a primary source of power. So we are essentially kind of capturing the hydrogen economy development in terms of its policies and regulations, um, legislation from a very early point. So anywhere in the 50 states where there is legislation or regulation that relates to hydrogen um, is essentially the types of things that come out on that report.
In that case, how do you see hydrogen fitting into broader policy landscape, and what impact do you think policy decisions will have on growth and adoption of hydrogen as energy source?
Well, as I mentioned, that hydrogen it's a storable zero carbon fuel. Um, it can be combusted in turbines or engines, although fuel cells are by far the more efficient, although albeit a bit of higher cost technology that makes use of it. One advantage of some of the fuel cells is that they can also produce hydrogen through electrolysis as well as generate power, and that combination of capability, right? They can obviously be dispatchable power generation, but they can also be dispatchable power consumption. So as the power grid moves towards higher percentages of renewables in the supply mix, you end up with increasingly steep curves. What they call in California the duck curve. And this is, so as during certain parts of the day, the solar power generation goes up, and then later in the afternoon, solar power generation tends to come back down. Well, solar power generation is not perfectly aligned with a lot of consumption. So there's some offsets there. The ability to use hydrogen, not just use it to generate power, but also use power to generate hydrogen, can help flatten some of those curves. As they get steeper, grid operators are trying to match supply and demand every few minutes, and they're constantly adjusting. And you can dispatch a hydrogen electrolyzer to consume power very quickly. Um, so they can actually support grid operations by consuming power when they're needed, as well as support grid operations by generating power when power is needed. So they can provide a very rapid response um, to help support the grid. They can consume renewables when transmission systems are not capable of moving all the power. So when you have curtailment of renewables due to transmission constraints, and those exist all over the country, um, that's a good way you can still use this electricity that could be generated but isn't because of transmission constraints. So there's a lot of underutilization of available resources now, and I think that will continue as we add more renewables to the grid. So hydrogen presents one option for adjusting for that, and batteries do as well. But with a battery, right, you're generally going to use that power later that day. With hydrogen, you can keep that power. You can generate it in March and use it in July or August, right? Whereas a battery can't do that. So we do have what I think of as super peaks. There are gigawatts of electric generation capacity that operates for 2 or 3 days out of the year. Um, you know, this is very cost inefficient capacity, but that's what's required to meet the peak, on those couple highest peak days. And so hydrogen presents an opportunity to generate fuel, have some generating capacity as well to help mitigate some of those times.
What do you think about hydrogen in geopolitical sense?
I try not to think about geopolitical things, Arnest. No, I mean I'm laughing, but I'm kind of serious. I mean there is, you it definitely goes beyond the scope of my current work, and that sense because we do focus on state level activities in the U.S. But I mean, geopolitically, there are a lot of ties to among countries related to energy. And not just trade, but we're talking fundamental economic inputs here, and that I think that leads to a lot of distortions in geopolitical relations, is because we wouldn't let those ignore these activities from this country or that, you know, except for the fact that we depend on these people for our fundamental economic inputs. It's a some of that, there are lots of ramifications for that, and hydrogen presents some freedom. The sun shines everywhere, the wind blows everywhere, and so I think it has the potential to counteract some of these dependencies and allow or remove some of the leverage that some countries have on other countries, and allow countries to act in a way that they feel best for them without risking the fundamental economic inputs for fuel and energy that they depend on.
When we compare the legislations and incentives, let's say in US, Europe, Asia, what do you think, who is running the game right now?
Well, um, I'm not as familiar with the incentives in Europe and Asia as I am in the US. Um, that's a tough question. I mean, so obviously Asia is a very large area with a lot of different countries that are doing a lot of different things. God, I hate to discuss Asia as one homogenous block, but there are
We can say country-wise. There's developments in Korea, in Germany, in other countries. There are ambitions in Africa to make green hydrogen and to export.
yeah, well, so let's say in some of the the I guess the longer term higher tech economies in Asia, like Japan and Korea, they've obviously been developing hydrogen technology and transportation technology, and studies in Japan were some of the earliest in the hydro world. And this fits with their resource, their natural resource profile, where they have limited fossil fuel based resources. They also tend to have a lot of train transportation, so this is a natural development for them. China is obviously a big player. I mean, but you could say that about pretty much everything. Every fuel source, every technology, everything that's manufactured. I mean, China is a huge market, and is still growing rapidly. So they have a lot of development and volumes. That I think they're just on the early part of the growth curve. Really, if they keep developing, they're likely to be the largest market for everything under the sun, at least for the foreseeable future. Um, the extent to which that engages the rest of the world, well, that remains to be seen. But just internally, right? And then you've got Africa. There are some trends there in developing countries, um, where they are kind of leapfrogging over the centralized grid infrastructure that we see more in the West and in more developed countries. Um, as solar power in particular has really allowed them to do this, that they can put in what we would call a microgrid. To them, it's just electricity in their village or town. Right? But hydrogen presents a way to potentially use that and store it, and so that they don't just need they're not dependent upon batteries and just what the sun can produce from their PV panels at a specific time. That they can store that and use it in different ways. Um, as far as Europe, and I think in terms of
In a, in
development and
places
you know,
in
yeah,
places where you have a high demand, and you need to transport hydrogen. How do you see what option do you see is the best for importing hydrogen? Let's say Germany will have to import.
Well, I mean, the most cost-effective way to transport large volumes of hydrogen is liquid hydrogen. Um, so I would say that, which is actually fairly similar to how not liquid natural gas is transported. Um, so it could come by ship, could come by rail, um, potentially pipelines. I mean, there are some hydrogen pipelines. I know of some in the U.S., but they're mostly used in the oil refining business, um, and they probably would need some technological improvements to avoid embrittlement of the steel, like internal liners or something to that effect. Um, so there could potentially be hydrogen pipelines. Um, it just the question then becomes, where do you get the hydrogen from? And a country like Germany already has, a fair amount of renewable curtailment during certain times, and in fact, quite a bit of Europe does. Right? And you've got a lot of hydropower in some of the Scandinavian countries. So I would say, there is some available electric capacity that could be used. As far as transporting it, it really just comes down to volumes. I mean, are you moving 100-pound canisters of gas? Are you moving, highly compressed gas in bigger, 20-foot long tanks? Or are you moving big, massive, compressed hydrogen volumes? And that's going to be a combination of the demand to where it's being sent and the supply where it's being generated. Who has the supply to generate it?
Jason, thank you for being my guest today.
Thank you for having me. It's a pleasure talking with you.